Okay, hi everyone. We're going to start with December 2017 problem number 1, Billboard. Okay, so if you haven't read this problem, you should read it on your own, but I'll just give you the general gist of it. There are 2 billboards and 1 truck. So, so there's 2 billboards, right? And then a truck covers a portion of the billboards, and you have to find how many units, like the area of the part that is still visible, that is like not covered by the truck. And so we're given 3 lines of input, right? So here, let's go to okay. So it goes like this. So the first number is your x coordinate. Oh, it's so slow. Okay, x coordinate, y1, x2, y2. And so this one is your billboard 1. This one describes billboard 2. And these coordinates will describe the truck. And so your output is basically the area of billboard 1 plus area of billboard 2 minus the overlap, right? So I'll call it overlap. Overlap from truck. Okay, so let's actually like solve this so that we can get 17. Okay, so let's first plot our billboard 1. So billboard 1 is 1. Okay, I'm omitting more people. Okay, it's 1, 2, and 3, 5. 3, 5. So this is billboard 1. Oh yeah, so this first coordinate describes the lower left. Oh my gosh. Okay. And the second coordinate is the top right. So I'll write this. Top right. This is lower left. Okay, I'm gonna graph billboard 2. Billboard 2 is 6, 0 and 10, 4. So I make billboard. Okay, so what is the area of billboard 1? We know that it's 2 by 3, right? 2 by 3. So we know that the area of billboard 1 is 3 times 2, which is 6. So we can fill this out that billboard 1 is 6. Here, let me make it bigger. Okay. Now, billboard 2 is 4 by 4, right? So we know that billboard area of billboard 2 is 4 times 4, which is 16. Okay, now we have to find the overlap from the truck. So we need to plot the truck. So now we're going to plot the truck, which has the coordinates of 2, 1 and 8, 3. So I make it into a box. So messy. Okay. Now we can obviously see that there are overlaps, right? There's one here And then there's one here. So we have to find the area of the overlap. So we know that this one is 1, right? It's just 1 square. This one is 2 by 2. 2 by 2 is 4. So our total overlap is 5. So 6 plus 16 is 22, minus 5 is 17. So that is our answer. So does everyone get how we get 17? Give me a thumbs up, like the emoji thumbs up, if you understand how we got 17. Okay, great. Okay, now, there are so many different ways to solve this problem. The most simplest way, so the most brute force way, so the most, like, you don't need to, like, think about it that much, is to do exactly what we did, like, make, like, a coordinate grid. So, method. This is called brute force. So, just like how we used a coordinate system, we can use a 2D array to just do what we did. So, hold on. Also, tell me if I'm going too fast. Let me know. I will slow down. Okay, so this method, we're going to use a coordinate grid. Our coordinate grid will be a 2D array. Okay. And the data type of this array doesn't really matter. You can make it an int 2D array, or you can make it a Boolean 2D array. It would be better to make it a Boolean because it uses less memory, so it's a little bit more efficient. So we can make it a Boolean 2D array for our coordinate grid. Now, there is something important. Let me go back to the problem. So it says here that the coordinates are in range 1,000 to negative 1,000 to positive 1,000, right here. My highlight doesn't, it's not very. Okay, see this? Okay, so what does this tell us? We can't have a, here, let me go back to the notebook. Okay, so when we have 2D array, we need to know what size. So what's the size? Well, if it's negative 1,000 to positive 1,000, we know that it's going to look something like this, right? Okay, it's so slow. Okay. Okay. So when we did this example, we had our origin at 0, 0, right? But can we have negative index numbers? No, right? Since our coordinate grid is now a 2D array, we can't have negative indexes, right? So instead of our origin being at 0, 0, it now has to be at negative 1,000, negative 1,000. Does that make sense? So it has to go like this. This is our new coordinate. So that means that if we have the coordinate negative 1,000, negative 1,000, this this now has to equal 0, 0, right? But how do I make this equal to 0, 0? we have to add 1,000, right? To both X and Y. So so this is like our smallest, right? Well, let's take the biggest. It's 1,000 by 1,000. If we add 1,000 to each, we get 2,000 by 2,000. That is our greatest coordinate. So our 2D array has to be able to hold, it has to have the index 2,000 by 2,000, right? So what does our size have to be? It can't be 2,000 by 2,000, right? Because if it's 2,000 by 2,000, that means the last index will be 199,1999, right? This is bad. We need to hold 2,000 by 2,000. So we have to have the size has to be equal to 2001 and 2001. Okay, does this part make sense? How we're going to have a coordinate grid, which is going to be our 2D Boolean array. And it's going to have the size 2000, it's 2001 by 2001. Does this make sense? Thumbs up. Okay, great. What is the time? Okay. Okay, let's look at now, since we have our 2D array, which is basically our grid, I'm going to create like a step of what we need to do. Steps. So the first thing we have to do is probably get our input, right? Get input, which is like all the coordinates. But one important thing when we get our inputs is this part. Remember here. We have to add 1,000 to each of these coordinates. So don't forget to add 1,000. Okay, our second step. After we get our coordinates, what did we do last time when we actually was solving this question? We graphed Billboard 1 and Billboard 2, right? So we have to do this. So instead of step 2, you can actually do this in this step as soon as you get your X coordinate and Y coordinate, you can just graph it. What I mean by graphing it is fill it in. So fill in Billboard 1, Billboard 2. We fill it in with trues, right? Because the default value is false. And we also need the area, right? So when we're doing this, when we're filling each of these boxes with trues, so think of each of these boxes. So when we count, or when we fill in, so these are all false, right? So when we go in and fill in these boxes with trues, we're going to count how many like trues we do, because that's exactly our area, right? So we have to count total area. Okay. So when I say fill, how do we do this? If you guys are not experience with nested for loops, I highly recommend practicing them because they are very useful with like navigating 2D arrays, right? So when I say fill, you have to have a nested for loop. So the outer loop takes care of the the x's, and then the inner loop, you generate the y's. So this means x is going to start with x1, right? And then it's going to go until x2. And then the inner loop, y, is going to start with y1 and then go until y2. So what does this look like? So let's look at the first billboard, for example. So the first billboard coordinates are 1, 2, 3, 5. All right. So we're starting with, so x starts with 1 and then goes on to 3. Y starts with 2 and goes on till 5. But doesn't like, it's less than. So it doesn't reach 5 and it doesn't reach 3. So this means when x is 1, y is going to be 2. And y is also 3. And y is also 4. And then when x is 2, y is 2, y is 3, y is 4. So do you see how this is? Oh no, you can't see it. Sorry. Here. So do you see how these coordinates are, they match up exactly to this, right? So that is how the for loop works, the nested for loop. Does anyone have questions on the nested for loop, like how you fill it in? No. So after you generate these XY coordinates, you would probably have to like grid XY equals true and then add 1 to the total area, right? Okay, so you do that for both billboard 1 and billboard 2. And then let's look back to our example. So after we've plotted the first billboard and the second billboard, what did we do? We plotted the truck and then we tried to find the overlaps, right? So that's exactly what we are going to do. So our step 2 is going to be, so go through grid with truck chord. So what I mean by this is basically go through the grid as if you're doing the same thing, like filling it in, like pretend you're filling it in, but you actually don't, because you really don't need to, right? Because you only need to check if it's already filled or not, right? So like, if you don't understand what I'm saying here, I'll say, pretend you're filling it in. Pretend you're filling. So pretend you're filling it in, but what we have to do is check if that spot is already filled. which means true, right? Filled is true. So if it's true, what does that mean? It means that either billboard 1 or billboard 2 is like there, right? So that is an overlap. This is overlap. So whenever we see an overlap, we have to subtract 1 from total area. Okay, yeah. So this one, since you're filling in, you also do need a nested for loop. Nested for. Okay. So does this make sense? Is there any part that was confusing? If you're good, give me a thumbs up. If it all made sense. Okay, great. Then we shall move on to the coding part. Okay, for time's sake, I just imported IO, java.io and java.util and made our scanner and out our print writer. Okay, the first thing what we have to do is get our inputs, right? So since we're doing the same thing twice, what I mean by same thing is filling in, so getting the coordinates for billboard 1 and then billboard 2 and then filling it in for both, we're basically doing the same thing twice. So I'm just going to create a for loop that repeats twice. Okay, now I'm going to get my input. So int x1 equals int dot next int. Right, and then I get y1, get x2, y2. Okay. And remember, when we get our inputs, we have to add 1000. Okay. And we should probably make our grid. So Boolean to the array grid equals new Boolean. The size is going to be 2001 by 2001. Also, I'm going to make an int variable for our total area. I'm going to set it to 0. Okay, now we're going to. Okay, so let me just. So this is get input. This one repeat twice for billboard 1, billboard 2. This one is filling in billboard 1 in grid. Billboards in grid. So again, for loop int x starts at x1 and x goes until x2, x plus plus. Int y starts at y1, goes until y2, y plus plus. And then grid xy is true. We set it to true, and then we add 1 to total area. Okay. So we basically completed step 1. So let's go. So we just finished step 1, right? We filled in the billboards with true, and then we added 1 to count. or total area. Now we have to go through the grid with using the truck coordinates and check if it's already true, and then we subtract. Okay. Let's do this. So, okay. I'm gonna just copy this. So this is our truck chord. And I'm going to just copy the same thing too. This is going with a truck, but now we have to check if grid XY is true, then we need to subtract, right? Total area minus equal 1. And then let's just output our answer in console first. Println total area. We should get 17. Okay, great, we got 17. So you would have to just say out. Okay, so this is the first problem. Does anyone have any questions about the coding part or anything about this problem? And if you don't, give me a thumbs up. No questions? Are we good? If we're good to move on to the next problem, give me a thumbs up. Okay, I'm gonna go to the next problem. The next one's a little bit more tricky. It requires a lot more thinking than the first problem. Oh yeah, so for this one, that was like the brute force way, right? If you submit it, you'll get something like this where it goes up to like 477. But there is a mathematical way to finish, like to solve that one. So if you want to know, yeah, just talk to me after class and I'll tell you what it is. But yeah, I'll also send my code on the Discord with the mathematical way too. Okay, next problem. So this is the shuffle question. This one's a little bit more tricky to understand, but basically this is 5 is n. So yeah, so this is n, this is the number of cows. And the next line is our order. And then the last line contains our 5 cows and their IDs. So this line is the cow's position at the end of 3 shuffles. So we're trying to find the order of the cows, like the initial order of the cows after it's been like shuffled. So let's go back to this. Okay, can you guys see my like whiteboard screen? Okay, great. Hopefully this works. Okay. I don't have that much time, but let's try to do the shuffle. So the order is 1, 3, 5, 4, 5, 2. This is our order. And let's just pretend. So this is at initial. I'm gonna just name them cow A, B, C, D, E. So basically what the order means, cow A, if you're in this position, you're going to go to position 1 next. So after 1 shuffle, A kind of stays in the same place. A. B is in this position. So this one, B is going to go to position 3. So B is going to go here. C is going to go to position 4. D is going to go to position 5. And E is going to go to position 2. Does this make sense? Oh shoot, I messed up. Not 4. C. So this is after 1 shuffle. So the order tells So if that cow is in that position, the order tells the cow where to go next. So after the second shuffle, A stays in the same spot. E goes to position 3. And okay, it's kind of slow, but you'll see it. So E goes to position 3. B goes to position 4. C goes to position 5. D goes to position 2. And then you do it again for the last time for the third shuffle. So it's A, D goes to 3, E goes to 4, B goes to 5, C goes to 2. So remember how the last line tells us the cows in the last, like after 3 shuffles? We just match it up to that. So we have cow. Okay, so the first cow's ID is like 1, 2, 3, 4, 5, 6, 7. I'm just gonna call that cow 1, okay? So this is cow 1, cow 2, cow 3, cow 4, and cow 5. But we want to know the initial, right? We want to know the initial. That's not the initial. The initial. So we need it in order A, B, C, D, E. So A is 1, B is 5. Sorry, that's a 5. C is 2, D is 3, E is 4. So if you look at our output, at the output, sample output, it's that. So it's 1, 5, 2, 3, 4. 1, 5, 2, 3, 4. So that is why that's the answer. Does this make sense? Give me a thumbs up if this makes sense. Okay, great. Okay, for this problem, there are a lot of ways to solve this, but the way I solved it is, since we're given the cows at the very end, I chose to just deshuffle it. So I just go back. So let's see. This is the position. Okay, it's 1, 2, 3, 4, 5. And this is the order. Order was 1, 3, 4, 5, 2. Right? Okay, so we're given the cow's position at the third shuffle. Oh my gosh, it's so slow. Okay, there you go. And the position is cow 1, 2, 3, 4, 5. Okay, so the key to deshuffling or like going backwards is to ask yourself, which position will tell this cow to come to this position right now? Okay, so I'll write this on so you have to ask yourself, which position would tell this cow to come to this position? Because that's where the cow should go, right? So let's try to find where the cows are after 2 shuffles. So cow 1, we'll see our cow in position 1. Cow 2 is in position 2, right? So where would cow 2 have to be to get to position 2? It's here, right? This position will tell this cow to go to position 2. So cow 2 needs to be in position 5. Again, let's check for this cow. So cow 3 is in position 3 right now. So where would this cow need to be last time to come here? It'd be here, right? Because this spot will tell the cow to go to position 3 next, which is where cow 3 is in right now. Okay, cow 4 is in position 4, so cow 4 needs to be here, right? And lastly, cow 5 is in position 5. This position will tell this cow to go to position 5. So if you notice, it's all, you have to look at this, the position. Okay, look. So after one shuffle, cow number 1 is still going to stay here. So cow number 3 is at position 2 right now, right? So we have to find 2 in order. 2 in the order array is at position 5, right? Here. So cow 3 needs to be in position 5. So this corresponds like this. So if they're here, they need to be in this position next. Cow 4 is in position 3, right? It's position 3. So it has to be in position 2. Cow 5 is in position 4, right? So it has to go to position 3. Wait. Sorry. Oh, yeah. So cow 5 is in position 4, so it has to go to position 3. And cow 2 is in position 5, so it has to go to position 4. And then now we do that one more because this will give us the initial. So let's do it. So 1, 4 goes to 3. Oh, no. 2, position 2 goes to position 5. Position 3 goes to position 2. Position 4 goes to position. Wait, I messed up. Yes. Okay, position. So 5 should go here. Sorry. And then 2 should come here. 3. It's because I messed up here. It should be 2. Sorry, this is so slow. Okay, so I highly encourage when you're solving this, try to get this. If you can make this, you can probably solve this problem. Okay. Let's try to write our pseudocode. Okay. Init. I know we didn't do this for the last problem because it was really simple, so we didn't really need it, but for init, we should get our inputs, right? So we have to get n, right? And then we also have to get the order and then the position. I'm gonna call this floor. This is basically like the cow's position because they're like dancing in this problem. So I'm gonna like call it like a floor. So like they're like moving. So we have to do something special about the order because if you notice here, we never use the actual numbers of these orders, right? We always use these numbers, right? Because they all point to this, right? So our order has to be 1, 2, 3, 4. Instead of the array 1, 3, 4, 5, 2, which is like the order, it has to be the opposite. It has to be like where it's pointing to. So 1 points to 1, right? 2 position, 2 points to 5. So if you don't know what I'm looking at, it's right here. So it's basically saying like what position is 2 in? 2 is in position 5. 3 is in position 2. 4 is in position 3. 5 is in position 4. So rather than the actual order number, the position of the order numbers is way more important. So that's why we're storing these numbers. All right. So for this, it would probably have to be like order, like input is equal to the position, which is probably like I, right? Because we're probably gonna try to get these numbers using a for loop, so the position would be I. Okay, floor, we can just get it normally. Floor I equals input. Okay, let's think about our solve. Solve. I'm planning to have like a deshuffle method that you can just call 3 times. So let's just call deshuffle 3 times. And then we'll probably have to print out floor, which is our answer, right? That will have, so floor after it's deshuffled 3 times, it will give us the initial, and then so we print out the initial, print out floor, the initial like position of each cow. Okay, now the hardest part is creating our deshuffle. Sorry, I spelled it wrong. Okay. In our deshuffle method, we need to, okay, so let's go back to here. So what actually happened, right? So let's look at this one. Let's look at this 3. So this cow is in position 5, right? Is at position 5, right? 5 in order is at position 4. So this cow should move to position 4. And that's why I moved to position 4, right? Yeah. So let's translate this. So cow is at position 5. This is just our I, right? Sorry. Yeah. And then 5 in the order is at position 4. How do we get this 4? It's right here. Right? This is just 4 is just order I. So this would just be floor at order I, which is like position 4, right? This is just 4, is equal to the current. So current cow, which is probably going to be like current I. I'm going to move this deshuffle. Okay, there we go. So in our deshuffle, like I said, we need to keep track. Okay, so basically we're changing floor, right? Look, we're changing floor. If you look here, right? So we need like a snapshot of like where the cows are right now, like currently. Because if we keep moving them, we're gonna like lose some cows, right? So we need to create a current, which is like an array here, equals copy of floor. This will give us the current cows. And then we need a for loop that goes through I equals 1 to n plus 1. Okay, so it's 1 to n plus 1 because everything, like all of our arrays and stuff, they start at 1. If you look here, even our order, it starts at index 1, right? Not 0. So that's why I start with 1. And then we go to the end of floor. No, we basically do this. Basically do this here. And that is it. Okay, so does anyone have any questions about this? Is there any part that's like, why did you do that? Or like, is there anything that's confusing? If you don't have any questions, give me a thumbs up. Or at the end of class, you guys can ask me questions. If this is too intimidating, you can ask me after class. Okay. Now I'm going to share my entire screen. Okay. Can you guys see my clips now? Okay, you can. Let's go to shuffle. So again, I just imported IO and util, and then I made scanner and print writer. So we need to create our static void init. Also, we need to create our solve, and then our deshuffle. And then here we just have to call init and solve, right? So let's look back. So what do we have to do in init? We have to get n, we have to get order and floor. So let's make sure they're static. So create static int n, static int order floor. So n equals and the next int. Now let's get order. We have to first initialize, right? So new int n plus 1. Oh, start with 1 and then go into plus 1. Okay, remember this one is order bracket input equals I. So it's order and dot next int, which is, and then I. Now let's get floor. Floor is new int and +1 again. And then floor is just regular, just floor I equals input. So floor I is input in dot next int. Okay, let's look back. Wait, can you see? Oh yeah, you guys can. Okay, so solve, we have to call deshuffle 3 times and then print out floor. So let's just call deshuffle 3 times. And then we can print out floor. But make sure we start at 1, right? Because we don't use the 0 index, so you don't need to print out the 0 index. So we just print out, I'm going to print it out in console first. Print out floor I. Okay, now we have to do a deshuffle. So deshuffle, we have to create an array called current, which is a copy of floor. So let's do that. So has to be int array called current equals. You can copy it the long way, which is like go through floor and then make it like set it equal to each other. But I'm just going to use floor.clone. That basically just copies floor and then sets it equal to current. Now we have to go through floor and we have to shuffle it, right? Deshuffle it. So for I int I equals 1 plus 1, I plus plus. And inside we have to do this. So floor bracket order bracket I is equal to current I. Floor order I equals current I. Like this. So if I run it, it should be 1, 5, 2, 3, 4. 1, 5, 2, 3, 4. Okay. I know I went really fast because we had to cover like 2 problems in 1 hour, but if you guys have any questions, let me know. I'll put the code in the Discord. I'll also put in Shun's code because I know her shuffle's a little different from mine. Let me know if you guys run into any problems. Oh yeah, and don't forget to get rid of the system dot out. And you print out in your out file. Okay, I just finished posting all the code. If you guys don't have any questions, you guys are free to leave. If you guys do have questions, please stick around and I will answer your questions.